Lieber here, presenting project 5, I believe it is, Traffic. I'll try my first model, my base model, which has one convolution layer using 32 filters, 3x3 zone, activation ReLU, and it has a pooling layer using max pool with a pool size of 2.2. I then flatten, and then have I have a hidden dense layer, 128 units, and then I have a final output layer here with 43 units using activation softmax in order to distribute each of the final units to a probability. So, and then I compile here. So I'll just go ahead and run what I have here, which is the base algorithm. We got here with the base model. The final model had an accuracy of 0.97, and the training model, that is, and the testing model had a final accuracy of 0.9353. So we see here that there's some overfitting. My next model, I added some additional layers. So I added an additional I added additional convolution layer and two additional convolution layers and two additional pooling layers using the same algorithms, except the second convoluted layer has 64 layers instead of 32. I mean filters, that is. And now let's run it and see what I get. How things change. Actually, it came out slightly worse, adding the two new layers, and the testing model actually had a higher accuracy of 0.948 as opposed to 0.93, and perhaps that's simply due to some of these additional layers that we added here. For my end, but there's still some, overfitting potential over here with the gap here. So I eventually added another hidden layer before the output layer, this time doubling the amount of units, 256. And I'll also add a dropout layer. And okay, so what I discovered here is that the resulting decrease in the accuracy is probably the result of the 50% dropout rate that I'm using. So there's much less data, and therefore the accuracy of the program has diminished. So for the final model, what I discovered is that if I change the pooling sizes to 1:1, I'm basically creating a lot more data for the model to work off, and ultimately this should deal with help with the accuracy, and the dropout clearly has relieved the overfitting issue already. So this one's going to take a while. I did figure out how to load saved models into the program, but I just want to show all the data, the record. So I'm just going to go ahead and run this program, and this could take a while. You can see here this particular model, ultimately with the additional pooling and convoluted layers, plus the additional two hidden layers with the last dense layer, with a 50% dropout, ultimately gave me the best results here. The final training accuracy was 0.98, and the final testing accuracy was 0.97.